Gonna have to forgive me, start going, and people can come in because I'm like a minute early. Um, okay, so one, forgive the setup. My laptop wasn't working. Some information I have is saved to my phone, and I sent it to email on my laptop, but now I can't get to the email without that laptop. So sorry for that. It's going to be a little weird because I'm going to have to reference my phone. Excuse me. Actually, I have three apologies. Second, I have a cough, so if I cough, I'm sorry. I'll try to excuse myself. Third, I completely forgot just now. Oh, the girls are in the house, Dudo and Melissa. So I was apologizing because this isn't how I wanted it set up. My laptop isn't working. So I'm going to have to reference my phone. I also can't screen share on this iPad tablet device that I'm streaming from. So I can't share my screen to show you what I'm reading or you can read along. I can't even show pictures of charts. Maybe I can show pictures. Yeah, that's not going to work. I can't share pictures. So you're going to have to take my word for it. And you can Google this yourself. I guess my fourth apology is I do not claim to be any kind of scientist. I'm just thinking and seeing patterns. I think that's what I do best, is just seeing patterns in truth. And it's kind of funny what I found. And I'll tell the backstory about that. Hey, Terry. So it was a little rough of a day, but I will get through. And this might not be as polished as I wanted it to be, but that's okay. I don't make a big deal about being polished on YouTube. Not because I don't love you guys and I don't appreciate you guys. I appreciate you very much. I'm just a simple, ordinary woman. So I'm not out to make anything from YouTube. I just do it as like a friendship diary or musings. So, oh, thanks, Dudo. Okay, so here's the backstory of why I'm making this little video. And you see the title, it says Sci-essences. I spelled it wrong. Essences? I spelled that completely wrong. I'll change that after this video. Wow, I'm like 0 for 3 right now. It's the essence of science, but we all know what science really is. So, excusing background noise from my daughter too. So I was cleaning up my daughter's messes and I noticed a book she brought home. I knew she brought it home, but I didn't look at it. It was some book about women who pioneered in science, such as NASA. Now she's going to use the ice maker. Okay. One sec. Are you done? Get your water. Okay. I can't focus with her around, so one moment. Oh, they can hear you. Okay. No, I don't want you on camera though. Go upstairs. She says, hey, she loves my YouTube friends. They're her YouTube friends too. Okay, so, well, this video is going to be really bad by the end. Hi, Tony. All right, so I was cleaning up her messes and I found this book that she had gotten from school. She knows the truths and whatever she can pick up and understand, she knows. This book was on the women of science, such as, I don't even remember their names because it's all just made up anyways. The lady who worked for NASA to calculate the moon landing, and the one lady I'm going to focus on, I actually had done a reading with another student of mine last year, and it was about this person. And the other lady I'm going to be mentioning was in this book. I thumbed through this book she had and took some notes, and I just thought it was funny. The book got more and more ridiculous as I read on. It was only like a 20-page book, a little snippet of what each of these women did to contribute to the study of space and stars and blah, 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 blah. So this lady who I first want to look at, and I'm going to look at this one and then one other. There's no point in looking at all of them. I don't even have time to do that. I actually threw the book away, so I'm not going to even reference that, because when it was just a child's book about, oh, look what these women did, but it's probably, it's really nothing. Funny enough, they mentioned 3 women from the distant past that probably knew more about the stars than any of these more contemporary women. So I thought that was funny. The first lady I'm going to look at, like I said, I'd read about her before with another student. That's where I first heard about her. And then when I saw it in this book again, I'm like, oh, there she is again. Now, like I said, I am not a mathematician. I'm not a scientist. But you can read between the lines that what does NASA and all these other people say? That they're so smart that they make you think that you're not going to be able to figure out what they're doing. I had to ask my dad a couple of things about this lady's formula. So you can kind of figure out where she's coming from. I will read from Wikipedia, and I will read from this, just some website I found about her. I will describe the graph that it shows. And what I'm saying is all of these things, despite having a big long formula that they made into a law, then they named after her, it's really not rocket science. It's not really that hard to, maybe the formula is hard to figure out, but it's not hard to do what she did. And I don't really know what she did. Interestingly enough, these women that were highlighted in this book, they said what she did, but they didn't give specifics. And even though it was a children's book, it wasn't specifically given. You'll see. It just isn't making sense. Wow, the title that I spelled wrong is really going to bother me. I will fix that. Okay, the teacher and me saying that's spelled wrong. I need to fix it, but I'll not get distracted anymore. Okay, so our first, and again, forgive me, I'm on my phone. I wanted to screen share everything, but I can't. You're going to have to look at my face and listen to my voice. So sorry about that. Okay. So this is titled, this article, about Henrietta Swan Leavitt. I think her name is funny. Or maybe it's Leavitt, but it's spelled Leavitt. So I think we should leave it. We should leave her law alone. Hey, Jess. Okay, so Henrietta Swan Leavitt's contribution to the field of astronomy is that she gave us the tools to map out the stars in the universe. And my head's cut off. I'm sorry about that. Okay, she gave us the tools to map out the stars in the universe. She discovered the correlation between period and luminosity. So period means how long in between the stars, how long in between stars are illuminated, like their twinkle. I'm not kidding. This is what they said she did. This helped turn the sky into a 3-dimensional map, allowing astronomers to solve the unknown in the equation, distance. Now, right off the bat, you know, it's not the distance they say, so who knows what she really did. A decade later, so she was in the early 1900s, 1919, 1920. So a decade later, it says, in 1929, the Edwin Hubble built off Leavitt's work to demonstrate that the universe has more galaxies than just the Milky Way. I hope I don't get blocked because I'm reading right from this, but whatever. Right. How did she do that? You're right, Pseudo. That's what I said. There's no way you can do that. It gets better. And now I also have to apologize. I had these thoughts initially about 3 weeks ago, and I feel like I should have written them down. Hey, Camelia. And I should have written them down. So I'm a little bit fuzzy on what I remember. So help me to figure it out and get it out. Okay. So she lived during a time, obviously, where women weren't in college that much. They weren't given credibility. However, she had wiggled her way through. Okay, so after completing her degree at Radcliffe in 1895, Leavitt's passion for the stars led to her position without pay at the Harvard College Observatory. So she's really just observing stars and other people's notes and other people's tracking with her naked eye, which I have something funny to share with you later about that. 7 years later, she was then hired as a computer, someone who computes, and it is in quotes, and began working for 30 cents an hour in what was widely known as Pickering's harem. So these were ladies who were mathematicians in these rooms at Harvard calculating who knows what. Nice. Okay, so these female computers were doing women's work. They were considered too frail to operate the telescopes at night in the cold temperatures. The women engaged in the painstaking tasks of studying and measuring photographic plates and comparing them to existing star charts to determine a star's position, magnitude, and brightness. Now, okay, again, I'm not a scientist. I understand that telescopes, whether they be in the past and now in the present, have capabilities to show the brightness and so forth of stars. Okay, I get that. She literally made a graph. Let's see if I can show you. Okay, so Leavitt found that as the mean brightness of these variables increase, the mean is the average, correct? Pseudo, are you a mathematician? Is anybody a mathematician here? Dang it, I need help. I forget what a mean is. Mean and average, I always forget. It's like 5th grade math, and I always forget unless I review it, which I'll have to because my daughter's in 5th grade. I did it a little last year and I can't remember. Anyways, for example, the median brightness of the star with a 65-day period is 12.5. Oh, good, pseudo, thanks. Okay, but stars with about a 10-day period have fainter mean brightness, about 14 1/4. Okay. So this graph that she charted for minimum brightness and maximum brightness, this is elementary stuff, okay? So I'm going to show you, okay. Literally, she's just tracking how they looked. This is elementary stuff. And don't tell me that people back then didn't understand. Okay? The period of variation, the days, is across the top. And the brightness goes from lowest brightness to highest. So how did these stars look? Bright. Now, they knew about stuff back then, seasons and times and things like that. I'm sure it's not hard to track these stars' brightness. What they're trying to say is she tracked the brightness to show their distance, but that's a bunch of BS. Okay. In 1908, Leavitt published her discovery of the period luminosity relationship. It's just word salad for seeing how bright a star is in a 10-day span. That is the correlation between how bright a star is and the time it takes for their star to go from bright to dim. Cepheid variable stars change how bright they appear from day to day or week to week as a result of their instability. Now, also, stars aren't unstable. So we have BS on top of BS on top of BS on top of BS, because what they're saying stars are not what they are. And there's no way you can tell how far it is based on how it's twinkling. So, nope. Okay, so during her career, Leavitt cataloged more than 2,400 variable stars, about half of the known total in her day, without ever looking through a telescope. I just think it's funny. Oh my gosh. Let me find her formula. Leavitt's law. This isn't going to be too long of a video because I don't have that much knowledge about it. I'm just making commentary, really. Okay. So of course I probably can't find it. It's really just a I can't even say it right now. It's trigonometry. I can't find it right now. So her law basically is showing the magnitude number, and then she divides or something or multiplies by the log, which is what a log in that functioning or calculus, is it? Pseudo, help me out. In math, a log is literally just the log, what you have logged. So she really just made this formula out of, whatever she was tracking, which literally she was tracking brightness to dimness, all that stuff, without looking at the telescope. I don't really know what that has to do with breakthroughs. So that's interesting. So the second lady, if she's a lady, is from, she had a Pulitzer Prize, I'm sorry, a Nobel Prize in 1993. Andrea Mia Gaze. Gaze. I didn't realize that. Okay, so now we got Leavitt and we've got Gaze. G-H-E-Z. What does she do? She gazes at the stars. That reminds me, what does, what's his face? Buzz Aldrin's mother's maiden name was Moon, right? So we have Leavitt's law, leave it there. We have Andrea Mia Gaze. She gazes up into the stars. It's probably Gaze. I'm just kidding. I'm going to say Gaze. I'm going to say Leavitt and Gaze. Okay. So she won the Nobel Prize. I'm going to read Wikipedia for her. She's an astrophysicist and a professor at the Department of Physics and Astronomy at the University of California in LA. I know, it's funny. Gaze and Leavitt. Okay, her research focuses on the center of the Milky Way galaxy. Now, we're not in the center of the Milky Way galaxy. You can't calculate that. You can't calculate anything where you're not there. I'm going to read a little bit about her, and I actually downloaded her 19-page article that she wrote with two others about what they studied. I'm going to show you some funny commentary about that. And like I said, this is not a scientific video. This is just think. I'm not that smart, and I can pick up on this stuff. So, so far we have Leavitt's elementary graph of how bright stars are, and she literally just tracked, oh, on day 1, it was 12.2 brightness, and on day 5, it was 10.4, and then by the end, it was 14.4 and or 14 whatever, and 14.75, and then it dissipated. Okay. They're really studying nothing. Okay, they just have all the verbiage and the term that we don't know, and they use that. Okay, so here's her career, and then I'll read some of the actual article that I thought was funny. And I really did read, like, I skimmed. I didn't read. I skimmed about 10 pages out of the 19 of this article that Andrea Gaze had written. Okay. Gaze's research employs high spatial resolution imaging techniques, such as adaptive optics system at the Keck telescopes to study star-forming regions and the supermassive black hole at the center of the Milky Way, known as Sagittarius A. She uses the kinematics, and I'm going to look up what kinematics are. Subfield of physics developed in classical mechanics that describes the motion of points, bodies, and systems of bodies, those are the stars, groups of objects without considering the forces that cause them to move. Kinematics as a field of study is often referred to as the geometry of motion. Okay, that makes sense. There is geometry in motion. And is occasionally seen as a branch of mathematics. A kinematics problem begins by describing the geometry of the system and declaring the initial conditions of any known values of position, velocity, and or acceleration of points within the system. Then, using arguments from geometry, the position, velocity, and acceleration of any unknown parts of the system can be determined. So right here, actually, I didn't read this before, but she has a lot of unknowns in the Milky Way galaxy, and then they have an unknown way of finding the unknown. Right. Okay. The study of how forces act on bodies falls within kinetics, not kinematics. For further details, see analytical dynamics. I'm not going to do that. Kinematics is used in astrophysics to describe the motion of the celestial bodies and collections of such bodies. Okay, so I'm going to go back now. All right, so here's what she did. She kind of discovered this black hole. Sure. Okay. In 2020, oh, she won in 2020. Her research was in 1993. The paper was in 1993. In 2020, Gaze shared the Nobel Prize in Physics with Roger Penrose and Reinhard Genzel for their discoveries related to black holes. Blah, 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 blah. Gaze was the fourth woman to win the physics Nobel since its inception. Blah, blah, blah. Okay. So I got this off of Wikipedia. I got her publication off of Wikipedia, and I downloaded it. And someday I probably will have to erase it because 19 pages on my phone takes up a lot of space. A lot of unnecessary space. Okay. So this is part of her writings. And actually, I just screenshot some of these funny things that I found in these writings. Okay. So a lot of what she did was the same or kind of like what Leavitt was doing. So these darker spots, sorry. The unfilled points are those stars observed with companions. And then I guess the filled ones are when they had companions. So it's star clusters, you know? So I don't even know about black holes and all that. Who cares? Okay. Who effing cares? here's some of the things that I highlighted from my screenshots. So really, this is what I was reading, and I'm not reading, skimming, excuse me. And I wrote this here. So let me read this for you. It says, the large fraction of T Tauri stars observed with at least one companion star suggests multiple stars are formed during the process of star formation, as opposed to being formed at some later time by capture. Okay, so this is why I wrote duh. They were observed that at least one companion star suggests multiple stars are formed during the process of star formation. Okay, if you have one star on its lonesome, twinkling, glittering, whatever you want to call it, and then it says it suggests that multiple stars are formed, well, you're looking for companion stars. So either stars have companions or they don't. That's really all that it says. Yeah, and it suggests it, right? So it suggests it. You often wonder, would Jesus smoke? That's a whole nother topic. We could go on that, but not right now. Oh, Keys is here. Hey, thank you. Oh, we got lots of people. Oh, thank you. 9 people. That's a lot for me. Okay, so first of all, they're saying we're looking for star companions, and there's multiple stars in these companion clusters. That's how I read it. They just said it in a more intellectual way. Okay, so then I have okay, so here we go. This one is part 5.1, completeness and multiplicity. The first few sections of this discussion compare the binary star frequencies of various groups of T Tauri stars. To ensure consistency in these comparisons, a subset of the survey is defined as the complete sample. That's an oxymoron, and they know that, a complete sample. No, a sample is a piece. And now you're saying something is complete. I thought that was just funny. It's word salad. It's all just words and blah, 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 blah. And let's confuse you to make you not understand what we're saying, because we're not really saying anything. That was funny. That's all I had really highlighted in that part. I don't even know what page I found that on. Here's what I posted on my little when I was going live thing. So the number 3 popped up a lot, 33 stars in a cluster, what they found or something like that. I'm not going to reference it completely well, and I'm not going to be very specific because it's a bunch of BS. They use the number 33 or 3 a lot. Here they have 66% of the identified T Tauri stars and blah, 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 blah. They used 66 a lot. They also used the number per the norm with these evil whoever, 69. A lot of 69s floating around in this article. 69, 66, 33, and 3. I'm not kidding. Like, you can download this yourself. It's if you look up Andrea Gaze, and it's on Wikipedia, and her published, it's there. I'm not making it up. It's just so weird, and I laughed at that. Of course it's 66% of the stars. Of course it's 69 star clusters or whatever. Weirdos. Fucking pervs. Okay. So then they started calculating noises. For brighter targets, the object's power spectrum dominates, but spikes typical of the detector readout noise are clearly visible. Again, the noise is clearly visible. Come on, guys. Noise isn't visible. They're solving the geometry. Yeah, I guess so. They also had a lot of calculus in this article, which that's not for me. Now, the other thing is, I hope I can find it because I did highlight something. Now I'm just taking bits and pieces. Like I said, this is a 19-page article. I only skimmed 10 pages. I'm just finding the laughability of this. One part says, these regions have many similarities. I'll start from the top. This is their sample. This survey was confined to the two nearest star-forming regions observable from the northern hemisphere, Tor-R and Ofsco. Okay. These regions have many similarities. In particular, they are both sites of active low-mass star formation. Okay, first of all, they don't know the mass of anything. They're not up there. You can't calculate anything, and I hope I can find it, but somewhere in this article they were talking about how they could calculate things that were only able to be calculated when they when you are there, present. So you can't observe anything unless you are present in that place of what you're observing. But somehow they said they did it. Yes, you're right. They do mix a lot of half-truths with their lies. You're right. Always. That's always what Satan does. I said that today. Deception is always, I said it a few times today, so it kind of set me up for this too. But it's all of life. Evil will always give half-truths. That's what Satan did to Jesus in the desert. It's what he did to Adam and Eve, and that's what he does to us. So if we're not paying attention, we'll see something, and he wants us to think that everything is black and white, but it's not, and he intertwines it. It's like a web. He's like it's just a web of lies, weaving in and out. And it's layers. You have to peel back layers of deception. Sorry, I'm getting really loud and weird. Sorry. So anyways, let me go back. Both regions have been extensively studied in a considerably, I'm sorry, both regions have been extensively studied in a considerably, this doesn't make sense, this is bad grammar, and a considerably body of literature on their stellar and cloud properties exist. Again, their cloud properties, I think that's what I was saying, the cloud properties exist. You don't know what properties exist because you're just literally putting colored in circles or non-colored in circles onto your paper from your telescope. And I get these telescopes can see a lot more than we see with the naked eye, like Leave It did, okay? What I was going to reference with Leave It was I literally summarized her findings as, with her naked eye, she saw the stars twinkling. And it made me think of that 90s song from Luscious Jackson, with my naked eye, I saw. So in the song, it says, with her naked eye, she saw the falling rain. She saw the rain falling down on her. So I made up this quirky, weird way of saying, Leave It, with her naked eye, saw the stars twinkling down on her. It was funny. I'm not going to sing it though, but it was funny. Okay. So they're just constantly saying, we have observed this, and we know these properties are here, and we know based on how we see the stars dimming and fading and how we're gazing up at the stars, this is what we're seeing. I already said the 66. So yeah. Let me see here. I have a whole page and I have a big question mark over it. So let me read to refresh my memory. I'll just read it and see what we come up with. So since the variables, now remember, variables are just parts of the puzzle. We all know, at least pre-algebra, variables is only part of your problem that you're solving. The variable changes, but how do they know? They're not there to see and observe the actual variable. Since the variables are probably at nearly, again with the grammar, since the variables are probably at nearly the same distance from the Earth, Their periods are apparently associated with their actual emission of light as determined by their mass, density, and surface brightness. You don't know their surface brightness. You're not there. They're literally just, there's another lady from that book of my daughter's, which is now in the trash and long gone. They literally just observed the colors. And so that's what they're saying. Oh, red means hot. Blue means cold, or blue is the hottest. So maybe they're saying that. I don't know. But stop it. You can't. Okay. So again, with these figures, and okay, if they know calculus and they're using things to figure out these things. Okay, whatever. That's not that hard. So, right? Okay, it's not a habit of them lying. Well, maybe this lady. Usually people that study this stuff, they really think they are studying things. It's the higher ups that they know they're lying. They don't care. It's not a habit. It's a lifestyle. They've chosen that forever. Hey, Skull. Okay. The faintness of the variables in Magellanic clouds seem to preclude the study of their spectra with our present facilities. A number of brighter variables have similar light curves. Blah, blah, blah. I'm not going to read that. It is hoped also that the parallaxes of some variables of this type may be measured. Probably and nearly. Yep, Terry. The facts known with regard to these 25 variables suggest many other questions with regard to distribution, relations to star clusters and nebula, differences in the forms of the light curves, and the extreme range of the length of periods. So they're really studying a lot of the same thing that Leavitt, Henrietta Leavitt, was studying, the periods of brightness. It is hoped that the systematic study of the light changes, I'm sorry, I'm not reading this properly. It is hoped that a systematic study of the light changes of all the variables, nearly 2,000 in number, in the two Magellanic clouds may soon be undertaken at this observatory. So this was 1993. I don't know what they've done. Okay, a little bit more, and then I think I'll be done. So, yeah, I think that's all I can, because you don't want to be bored to death. I was really like, my mind was trying to wrap around what they were really saying. And at one point when I was reading this article, I was thinking, it came to my mind that they know that stars, or they think they know, excuse me, that stars are far away and also huge. So like in their eyes, the sun is a star, right? And the sun is huge. So they were actually taking these micro type measurements for something macro out there. Now we don't know what it is or what they are or whatever, but even just that common sense, common sense will tell you that that doesn't make sense. You can't. It's just like I taught my students a little bit about the metric system, very little because they can't understand a lot, sadly, as fourth graders. But you tell them, we're not going to take a meter stick. I even showed them just basics. You're not going to take a meter stick and measure, how tall the Sears Tower is or whatever. You're not going to measure yourself in centimeters. You're not going to measure in micro type measurements for something macro. So that struck me as interesting too. Now you can leave what I say, leave it, or you can take it. I'm just saying this is what I found from just stumbling across stuff. I will post the link to that with my naked eye video because it's just funny and it's fun to flash back to the 90s. But it's just funny because leave it. That's what she said. With my naked eye, I saw the stars twinkling. The song was in my head and I was singing it that way in my head, but I'm not going to sing for you. Not today. Okay, I did find Leavitt's formula. Okay, so I'll just show it to you and then I'll read it to you. So it says MV 2.76. Now this is what I was talking about, the log. That's just her logged data. Okay. No Space Rangers. MV equals negative. Now this is in brackets. 2.76 and then log to the 10th power P minus 1.0 minus 4.16, where P is in days. If logarithms are a faint memory, you may wish, okay, yeah, it was a faint memory. I had to ask my dad, like, what is log? And actually, so I'll show you what my dad said. When I asked him about log, because when we were little, he used to kind of boast that he was taking these math classes. Now, my dad worked for AT&T for a long, long time. Just a side note on my dad. And he, oh, thanks, Cole. Yeah, go to Keys to the Truth. He's got a ton of great stuff. I love your channel. He's very smart. My dad was told by his father he should have been an engineer because he should have. He's very good at math and science. He just has a mind to remember a lot. And so I could just tell him what was a logarithm, and he said, oh, it's powers and exponents. And if I showed him, this formula, he could probably figure it out. So my dad is smart. He doesn't think he is, sadly. But he knows his stuff. So that's what he was telling me. It's powers and exponents. And so that's what it came to. This Leavitt woman logged the dimness and things of what she was looking at on these plates. A lot of the women up until the 60s and 70s, that's what it said. These women were human computers. So they literally were just computing. No, I don't know. The women were just computing all these numbers. Now, I don't know if they found, oh, here she comes again. Sorry. She has no shame and not shy tonight. Okay. Are you finished? I don't want you on camera. Nope, you can't be on camera. Go upstairs. Go. Real life. Go. Okay. Anyways, this is usually why I do things late at night, because she's sleeping and she distracts me. That's okay. She's funny. She knows she's funny. She's very smart too. She understands math a lot more than I did in 5th grade. So yeah, that's all I was saying was Leavitt's law is this formula, and she's really just taking these computations, and it's not hard to subtract or divide or multiply with data that you are collecting. And funny enough, that's what these scientists do, and they just collect data. And that's what I actually was explaining in science to my students. It was literally the definition of what scientists and engineers do. They collect data and they do these experiments over and over and see where the variables are. They didn't even use the word variables because my 4th graders couldn't even handle that word. They can barely handle data. So that's what it is. You collect all these numbers and then you put it out there. Anybody could really do it. And I bet you, I'm not tooting my own horn. I think I could probably use this law and understand it if someone showed me. All of you could too. So, like I said, this is just more my commentary on a couple of these pioneer women that study how bright the stars twinkle. That's really all they do. Andrea Gaze and Henrietta Leavitt. So I would say leave it alone and gaze up at the stars, because you could probably see and track the same things these women who win Nobel Prizes and who get their names in books did and do. Funny enough, it being Thanksgiving tomorrow, my cousin has his doctorate in astronomy. He teaches astronomy and geology college courses. He does believe he's a lot smarter than any of us, which he is. Hey, I can't do this math easily. I haven't really tried, but he likes to tout around his knowledge about stuff like this. So I definitely do not bring any of this up on holidays, because he's proud, and he really just he doesn't listen to anybody. So I don't even go there. However, I'm sure he knows about these women, and I'm sure he knows what they're doing, and I'm sure he can figure out the formulas too. He wouldn't give anybody else credit, especially me, a lowly teacher, give me credit for knowing anything about anything. But it's interesting that tomorrow I'm seeing him, this doctorate of astronomy, and here I'm talking about this. That's why nobody knows that I have a YouTube channel besides like my husband. And you can see why. So yeah, that's all I have. Sci-essence. It's the essence of science. It's they're doing what they do best, and like I said, word salad and lots of 3s, 33s, 66s, and 69s. Ugh. Wackos. And I'm at 11 viewers. Thank you. 11 is the angelic number. You want to know something else? Today is 11/22, and I've always loved this date. I don't know why. Nothing significant has ever happened in my life on 11/22. I did want to get married on 11/22, but that didn't work out. So I love that I have 11 viewers. I love that it's 11/22. 2 is a number of like pairing and truth and working together, I guess. So, yeah, I'm glad it's good dinner entertainment. Pseudo, thanks for coming. Yeah, I'm going to stop here. So have fun. You can go look up Henrietta Leavitt or Andrea Gaze. Leavitt is Leavitt, and Gaze is Ghez. So you can go get. All right. Bye. Blessings.